Okay, hello everybody. Thanks for tuning in. We're going to be doing just a brief review of how to determine wind direction on surface and upper level maps. Hopefully this will be in preparation for your exam that's coming up in 2 days. So we'll get started, and just to start off the review, we want to remember that winds are named by the direction from which they come. So for example, a wind blowing from the west to the east, that's something that we call a west wind. So when you're looking at the maps, remember the meteorological convention is to name winds where they're coming from. Also, another point is that winds blow clockwise around anticyclones, so that's areas of high pressure, and counterclockwise around cyclones, or areas of low pressure in the northern hemisphere. So these are two concepts we've been talking about since the first lecture, and hopefully these are pretty common to you by this point, but this is really the basic starting point when you're trying to determine the winds on an upper level map. Okay, so let's also review this concept of geostrophic balance. So here are lines on a map. So if you're looking at a 500 millibar map, these are lines of constant height. Or at the surface, these are isobars, lines of constant pressure. And we have high pressure down here at the bottom of the screen and low pressure up here at the top of the screen. So the first force is the force that's directed from high to low pressure. That's what we're calling the pressure gradient force. So that is always directed from high pressure to low pressure. And the second main force when we're looking at geostrophic balance is the Coriolis force. And that always goes opposite to the pressure gradient force. So the combination of these two is what we call the geostrophic wind. So in this case, if we had high pressure at the bottom of the screen and low pressure at the top of the screen, these two forces, the pressure gradient force and the Coriolis force, would combine to give us a geostrophic wind that's blowing from the left-hand side of the screen to the right-hand side of the screen. So if this were a typical orientation of directions, north, south, west, and east, this is what we would call a west wind, geostrophic. Now, in reality, the isobars and lines of constant height are not straight, they're curved. And that's the case where we call this a gradient wind. So a gradient wind is a type of geostrophic wind. And the only difference here is that we have an additional force. That's called the centripetal force. And that's directed towards the center of curvature here. And the only difference in this case is that the gradient wind still bends along and parallel to the lines on the map. So the pressure lines or the height lines. So you still have flow that blows parallel to these lines. In this case would be going from west to east, generally following the contours. So when you're looking at the maps, this is where you want to start out. You want to find wind that is blowing parallel to these contours or these lines. So the gradient wind, again, that blows primarily parallel to these lines. And if we're aloft, that's all we have to do. All we worry about is finding winds that are parallel to those lines. At the surface, though, we have to make one additional correction, and that is the effect of friction. So when you're close to the surface, the wind that's blowing over the trees and the land surface and the buildings, there's drag on the atmosphere. And that effect of friction weakens the Coriolis force. Because remember, this Coriolis force works and operates in conditions where the flow is sufficiently fast and on large scales. So if you slow the winds down because of friction, the Coriolis force isn't as strong. And that means in turn that the pressure gradient force is stronger. So as a result, we see winds that tilt inward toward areas of low pressure at the surface and outward from areas of high pressure at the surface, and that angle is about 30 to 45 degrees. So again, this correction about the effects of friction only apply at the surface. Otherwise, the winds are blowing parallel to the isobars or height contours. So here are the steps that you need to do when you're looking at a map in order to figure out what the wind direction is. So again, remembering that the winds are named from the direction in which they're blowing, and that the winds are blowing basically parallel to the contours. We want to find the closest area of high or low pressure. Now this is important because it tells us whether or not the mean flow is clockwise or counterclockwise. So once we figure that out, and we know what the mean flow is, we find the direction of the wind that is parallel to the contours. If we're looking at a 500 millibar map or an upper air chart, that's all we need to do. But if we're at the surface, we have to apply that final correction, that rotation for the wind direction, and that's another 30 degrees towards low pressure or away from high pressure. All right, so here is an upper air 500 millibar chart for this week. So let's start out by finding the wind direction here at this location marked A. So what are the steps? We want to find the closest area of high or low pressure. So we have this big ridge over the Gulf of Mexico, this high pressure. So that means that the flow around this high pressure is going to be clockwise, like this. And now since the winds are blowing parallel to the wind contours, we see at location A, the winds are coming in from the west. So that means that we have a west wind at location A. Remember, upper air chart, we just find the winds that are parallel to the contours. So let's try this location up here, location B, up over the Canadian Maritimes. So we find the closest air mass, and that's an area of low pressure. So in this case, the winds blow counterclockwise around low pressure. So the winds are blowing in this direction around the low. So that means that as we go around this area of low pressure, the winds are generally coming from the south or the south-southeast at location B. So again, we find the area of closest high or low pressure, and we follow the winds that are parallel to these contours. So now let's look at the surface chart for this week. This is something a little bit different again. So now remember, we want to find the winds that are blowing parallel to the contours, but because this is at the surface, we apply that correction for friction. All right, so location A over the South and Gulf states. So we find the closest area of high or low pressure, and that's this surface low pressure over the Gulf of Mexico. So that means that the winds around this low are generally going in this direction. We're going counterclockwise around the low. So that means that the mean flow coming up over Georgia and Alabama and Mississippi is primarily out of the southeast. Now, because the effects of friction have to be taken into account, we're going to tilt the winds 30 degrees inwards towards low pressure. So that means that this southeast wind is really an easterly wind coming in over this region. So that would be the wind directions around this area of low pressure. All right, so let's look at this area of high pressure and the winds over New Jersey. So at location B. So we find the closest area of high or low pressure, and that's this high. So the winds around this high are going clockwise, like this around the high pressure. So that means the winds are coming primarily out of the north if we're parallel to these contours. Now, if we make our correction for friction, or 30 degrees away from high pressure, that means the winds are primarily out of the northwest over New Jersey in this map. So again, very important to know whether or not you're looking at the surface or the upper air, because that helps you determine which correction you would need to apply, if any. Okay, so the steps in review: you want to find the closest area of high or low pressure, determine whether the mean flow is clockwise or counterclockwise, and you want to find the direction of the wind that is parallel to those contours. If it is a 500 millibar map or an upper air chart, stop, you're finished. Remember, the winds just blow parallel to those contours aloft. But if you're at the surface, you want to rotate the wind direction another 30 degrees toward the low pressure or away from high pressure. Okay, so that ends the slides that I have. If you have any questions, you could type them in the chat box on the right, or feel free to send me an email. All right, thanks for watching, and I hope this helps with your studies.